Bonjour. That's all the French that I know. My apologies. I have a French chief of staff, I have French investors, my daughter is learning French, so I'll pick it up for next year. I'll be able to say a little bit more, I promise. So the slide here this says the state of AI engineering. I'm not going to talk about the state of AI engineering. I don't think that's my talk to give. I think that's Swix or Ben. I feel like actually Swix did some version of that last night. But I've spent 2 decades of my life in databases and knowledge representation. And so instead, I'm going to talk to you all about managing state in AI engineering. And more specifically, over the last couple of years, we've observed hundreds of projects built inside of big companies and small companies, building AI applications. And I'm going to share some of the observations from that. Last year in San Francisco, I did a very hands-on practical talk about GraphRag and the benefits of GraphRag and how you can get started with that. This talk is a little bit more high level. It's an opinionated view of where I believe the data layer for AI should go. Or in other words, we've identified 4 properties of a kick-ass data layer for AI applications. All right. But before that, let's start with a little bit of context engineering. Who here knows what context engineering is? Raise your hand. The morning gymnastics exercise is going well. Fantastic. Karpad, I think, had a good one-liner for it. Context engineering is the delicate art and science of filling the context window with just the right information for the next step. It was coined by this gentleman, Dex Worthy from HumanLayer, who wrote a really phenomenal blog series called 12-Factor Agents, which I really recommend. For those of you who haven't read it, it's a great treatment. And in Factor 3, he talks about context engineering. He has a really, really simple intro for it. Everything is context engineering. LLMs are stateless functions that turn inputs into outputs. Therefore, to get the best outputs, you need to give them the best inputs. So simple. 3 sentences, a really good kind of summary. And he went on and he showed like a Venn diagram of what context engineering is here. And today in this talk, I'm going to focus about the 3 main sources of state in AI engineering. The state out of your RAG corpus, the state out of your agentic memory, and then the state in your application. I call this the state in AI engineering. Okay, but before that, we're going to talk a little bit about a brief history of application architecture. So I'm going to start by bringing you back to ancient times, many, many years ago, before 2022. And we were all building some version of simple CRUD apps. And lots of architectures around, but at some high level, this, I think, was the canonical architecture. We have some UI, we have a backend, we have a database, right? We store data in the database and in object storage. More specifically, we put our structured data in the database. We put our unstructured data into object storage, and then between kind of the UI and the backend, we speak JSON, which is semi-structured data. Very simple, but then something happened, right? ChatGPT was launched end of 2022. That's why we're all here. Swix coined the AI engineer term 9 months later, mid-summer 2023, right? And we all started building chatbots, right? We started building relatively simple chat applications, right, that sit on top of some kind of orchestration layer. We stuck a bunch of our data in unstructured form into what? Into vector databases, right? And so these very simple but pretty powerful applications ran on top of, honestly, a reduced version of our unstructured data, like the embeddings, right? So that's kind of what we did in 2023. And then in a very gross annual simplification, right? It's only been 2 years that we've been doing this, right? 2024 is when everyone started talking about agents, at least talking, right? Debate of how much was doing. Towards the end of 2024, Anthropic launched MCP, which really helped us think through what tools look like and simplify tool access in agents. And so as we sit here in 2025, we can see a stack is starting to form, right? At the top, it's not just simple chatbots anymore. It's a real application, right, with some AI embedded, AI features on the side or at the core of it. The former orchestration layer now consists of one or multiple agents, and of course there's a big debate between single agent versus multiple agents, that wrap prompts, they use tools, they use memory, right? They use one or multiple LLMs as part of that, right? And then we have the data layer, right? So what's going on then in the data layer? The stack is starting to form, but that really is the upper half of the stack. So let's double click and spend a little bit of time on the lower part of that stack. So we started out with vector databases, right? But after a while realized that, you know what? Just querying on unstructured data in a semantic ANN approximate sort of a way, right? It's powerful, but it's actually not enough. And so the vector databases realized that, you know what? We need support for structured data as well. And they tend to call it metadata. And you use it in metadata filtering, for example, right? But then at the same time, there's obviously a bunch of other databases around that we started using for retrieval. It's the relational databases, the document databases, and graph databases, for example. And we all said, you know, that whole semantic search thing, that's kind of cool. We're going to add vectors as a feature, right? So here what we have is we have unstructured, like a data store centered around unstructured data, which is adding structured data. And then we have, I don't know, let's call it Postgres, which is centered around structured data, that is adding support for unstructured data, and a database like Mongo, with JSON semi-structured data, that is adding support for unstructured data. So it's a real party down there, and there's a lot of different models. Everyone's kind of adding what the other folks are having, and honestly, it's a little bit of a mess. And the big question then is, where is this going? And we spent a lot of time thinking about this. What's really required in order to have a kick-ass data layer that makes it really easy to write AI applications? And we've identified 4 properties for a kick-ass data layer for AI applications. 4 properties, and I'm going to walk you through them one by one. Okay. So the first property, you can hear how kind of I talked about it in the state of the union of the data layer, right? Where we're going with this. The first property is, I believe that in order to make it really easy to write AI applications, that requires you to be able to have a data layer that in a very easy way manages unstructured and structured and semi-structured, all 3 types of information in a single data layer. And do that well, right? So store and retrieve, of course, but you want to index them, you want to be able to handle transactional scope across them, and all of that kind of stuff. So that is the first property, the ability to handle structured, unstructured, and semi-structured data. Okay, so let's talk a little bit more about unstructured. Let's double and triple click on that, right? Okay, for property number 2, what do we need to do? What do we want to do with unstructured data? So we just talked about how important it is for all to be able to handle all 3 types of data. But, of course, the fundamental currency of an AI application is the unstructured data. That's one of the L's in LLM, large language model, right? But there's another observation that's been happening as well over the last year or so. There's a lot of talk, and you heard it yesterday from Mistral, which is AI applications. They are, well, they're applications. There's a lot of software engineering involved in this, right? And if you want to write an application, you probably want to do that with types. You want to have structures and objects and classes. And if a lot of your information is unstructured, the question then is, okay, so we have an application. That application is handling people. You probably want to have a person class. But then you have a lot of unstructured data in your data layer. And so you need to be able to bridge somehow, take the data out of your unstructured data layer, and reflect that in persons and objects and types up in your application so that you have a convenient and good developer experience, right? So how do you do that? So let's talk a little bit about that. Let's say that we have an unstructured source. I'm not sure if you can read it in the back here, but we have some kind of text, maybe out of our RAG corpus, which has 3 sentences. Andreas is here today. He is a carpenter. Shout out to ABK, right? 3 simple things. So step one here is to identify the entities, the concepts, the things out of that data. That's called named entity recognition. It's a technique that has been around for a while, actually, quite a while. And we identify Andreas and he and ABK. And then you can look at this and you can see that the people here, the human beings, we can read this and instinctively we feel like this is probably the same individual, Andreas and he and ABK. So how can we resolve that? How can we figure out a way of combining these things? That is called entity resolution, and that's the next step, resolving these into a single entity, right? Entity resolution. If you look at this data right here, it's actually structured data. This piece we can easily reflect up in our objects in our application state. This process right here, the named entity recognition, the entity resolution, is going to be a really important part of writing applications in a convenient way for developers on top of unstructured data. So the second property of a kick-ass data layer for AI application, I believe, is the ability to consistently and reliably extract entities out of unstructured data. So that's the second one. Okay, the third one. So let's say that we're building an application, and that application is for an online furniture shop retailer, right? And you can see the application. We have some kind of a central part where we have a product gallery of some sort. It has some weird Nordic name for the table, the Kiroda table, right? And then we have an AI-powered community forum on the side. We probably have some kind of an AI bot helping out with assembly instructions, right? The data layer of this might look something like this, where we have a product database, right? We have the purple boxes in here. We have some kind of a bill of material table. We have kind of a product issue tracker table, and they're kind of joined up in some way. But that assembly bot that helps out with assembly instructions on the community forum, well, it probably needs to read data out of some product brochures, some assembly guides, right? And so we put that in there as well, and we've extracted the central entities out of that unstructured data like we just talked about. So that's the first piece. But then we have this community forum where there's a lot of chatter, right? And people are talking, they're logging on, they're maybe asking for help, they're commenting. And there's individual chat history memory, but we've also extracted entities. And in particular, we're focused on the entities that are globally interesting. In this case, we have a user called ABK, who's a carpenter, and he wrote that, you know what, for the Kiruna table, the assembly instructions weren't really great, but when I applied 2 drops of wood glue to the table to the table legs before step 8, then all of a sudden, I could easily assemble it. So of course, when we look at this, we would like our AI assembly bot, right, to be able to answer questions not just based on the data over here, but also out of some of the stuff out of our agentic memory, right? But of course, the problem we end up with here is that we have multiple Kiruna tables in here. So in order to really be able to answer not just with the data out of the assembly guide, but out of these instructions, we need to be able to link them together. There are 2 ways you can link them together. One is link during retrieval time, right? So you query across all your data sources. You want to find the Kiruna table, right? And you do that in retrieval, and there you go, right? That's one way. The second way is you do it in some kind of a unified layer where you link it together in the data layer of the stack. I think the second is going to be by far the most powerful for most applications out there for 3 reasons. The first one is performance. If you do multiple retrievals across multiple of tools, you will frequently end up with dependencies between those retrievals, which adds up the latency. You also have to manage intermediary results, which frequently ends up being relatively big, actually. You re-implement joins in that application layer, and it adds a lot of memory requirements. So that ends up being tricky. When you have real production type deployments, for trivial small stuff, it's always doable that way. The second reason is, we just talked about this, actually it's high complexity. we spent 15 years trying to implement joins well in the Neo4j database, and we're still working on it. It actually is pretty non-trivial to make that work well. And then the third, there's actually a reliability piece. Imagine that there was like a trademark dispute or something like that for the Kiruna table, right? And then we have to change it, right? So if we have to change it, then all of a sudden, in this world, right, we have to do some kind of a text search across all of our data sources, right, and update them, which is entirely doable. But we all know that that kind of start is a little bit messy, especially in production, especially at scale. If you have it all linked up in the data layer, it's a trivial change that automatically propagates across the entire state in your AI application. So I believe that the third property of a kick-ass data layer to make it really easy to write AI application is an ability to link entities across persistent agentic memory and into your application data, which tends to come out of your RAG corpus. So that's the third property. And then the fourth property, speaking of the RAG corpus, if we go back to prehistoric times again, we think about the CRUD app. One way of thinking about this is that it has structured data and unstructured data in the data layer, which I talked about. Another way of thinking about this one is that all the data in here is first-party data, right? So what do I mean by that? What is first-party data? Well, in this context, in the context of application development, first-party data is the information that your application directly collects from its own users. It's data that you own. And a couple of examples, profile data, right? The names that people type in, their preferences, that kind of stuff. But also activity data, how long time did you spend on various things, right? Transaction data, those kinds of things. And if you think about to that CRUD era, basically all the information for most of those apps was first-party data. I'm sure there were some integrations and stuff like that, but by and large, most of it was first-party data. But then if you look at our more modern AI app, and we see that the first-party data really sits here in the purple boxes. But the yellow data there at the bottom is actually derived data. It's coming out of the RAG corpus, the assembly guides for the Kiruna table. And what this presents an interesting tension. Because on one hand, this is fantastic. We want to commingle first-party and derived data so that when we reflect that state up into your application, the Kiruna table has the Kiruna table object in your TypeScript application has all the relevant information for it. That's the best developer experience. It also leads to better queries and retrieval. So we want that. The flip side, though, is we have to treat them differently. And a great example, that's where we have to have the ability to treat them differently. A great example of this is, what if that trademark dispute thing happened and we wanted to change the name of the Kiruna table? Or maybe we wanted to add to the instructions, right? People handle this differently in RAG, but a very common pattern, probably the best and simplest pattern today, is that you drop all the derived data and you recreate it when the RAG corpus changes, right? Some people try to apply change sets and stuff like that, but I think that's tricky in reality today. So then we would drop all the yellow stuff, right, and recreate this when the RAG corpus is updated, which is great. But if it's commingled with the purple stuff, you don't want to accidentally kind of cascade across that and delete some of that information. So the fourth property of a kick-ass data layer for AI applications is the ability to disambiguate between first-party data and derived data, so that we can handle it differently in the application. It'll be different in different types of application because people have different strategies for it, but it's always based on this ability to know, is this first-party data or derived data? Okay, so we've gone through a little bit of history. We've talked about these four properties of a kick-ass data layer for AI application. Properties that are required, I believe, in order to make it really convenient to write great AI applications. It's the ability to handle structured, unstructured, and semi-structured data. It's the ability to extract entities from unstructured data, to link them between both agentic memory and your RAG corpus and application state. And then finally, the ability to disambiguate between first party and derived data. So I don't know if any of you are work in big enterprises and you're buyers of application software. I think I've seen this many, many times happen where someone is in front of me, a salesperson, and they talk about, okay, here are the needs that you have, and then magically they show up with a product that solves exactly those needs, right? So that is not what we're trying to do here. These are our objective, intellectually honest observations. We don't have this at Neo4j today. But the reason why we're here, the reason why we spend so much of our cycles focused on AI engineers is that this is, of course, where we want to go. And as the CEO, I think I have some amount of influence, at least, over the product roadmap. So this is exactly what we're building towards at Neo4j. So let me give you a little bit of a quick demo of the first two principles, which are not perfect yet, but they're really making progress really fast, and what it looks like in Neo4j. So imagine that we have a Wikipedia page that we want to, as an example of unstructured data, that we want to add to the database, and we're going to see our ability to look at structured, semi-structured, and unstructured data in one platform, and the ability to extract entities from unstructured into structured form. So in theory, this should work. So here we have the Wikipedia page for Paris, right? We take that and we copy-paste the URL. We go into the knowledge graph builder here, which will upload it, and it's going to start processing. So a couple of things will happen right now. We start processing and chunk up that Wikipedia page, and we put it into the graph in two forms. The raw data, the chunks, but then also the extracted entities. And what you can see here is both of those things at the same time. We're going to remove the entities for a moment, and here you have the raw unstructured data. These are the chunks of that Wikipedia thing. But much more interestingly, of course, are the entities. Those are the ones that mean something to us, to humans, to applications. So here you see that we've extracted like some demographic data. It's too hard for you to see, but it says British citizens and US citizens in the city of Paris. It's in the country of France. And then it's automatically extracted notable individuals, right? So these are the, whatever this color is, greenish, something color. You can see a bunch of really notable individuals out of Paris, which is a very humbling list of people, by the way. This is Igor Stravinsky as an example right now. So this is all automatically extracted from that unstructured source. And you can imagine that once you have these entities, it's really easy to reflect them out into your application state in terms of typed objects. It's also really easy to query across them in a semantically useful way. So those are the two properties at play here, as an example. So that's it for me. The four properties that I believe are required to build great applications. If you think this is interesting and we're going in this direction, Neo4j is available for free in our cloud service Aura, so you can check that out, the QR code. We have a great Graph Academy where we teach people how to get up and running and build these types of applications. A few weeks ago, I don't know how many here are at startups, a few weeks ago we launched a startup program where we give away free credits and stuff like that, but maybe even more importantly, we're building a team of experts that help startups get up and running with Neo4j, right? So apply for that at neo4j.com/startup program. And that's it for me. Thank you very much. Thank you.